Hello, and welcome to Getting Started with C, Part 2. In this episode, we will be covering variables and data types. We left off the last episode with code that looked a little bit like this. And at that point, I mentioned that there are a number of things that we were going to explain at a later date. Specifically, these complicated parts of our main function definition I said we would describe at a later point. And in this episode, we're going to start unpacking a little bit about what this means. These are called variable declarations, and they are a way of telling our program about some information that we would like to store or retrieve. Let's start with asking ourselves, what actually is a variable? Those of you who've programmed before probably have some idea about what a variable is, but just to keep it simple, let's go over it all again. Essentially, a variable is like a box where we can store some information that we would like to retrieve at a later date. In order to make this process a little bit easier, we might decide to give the box a label so that once we've got a bunch of other information, we can always find it again at the end. In this example, we would have some data stored in the random box and some stuff stored in the my data box, and the ABC box might store something else again. But we can tell them apart because of their different labels. In C code, it looks a little bit like this. However, in addition to just the names and labels, you might notice there is some additional information here. These are called the data types, and they just are a way of identifying what kind of information is stored in each box. In general, a C variable declaration follows this format. We declare the data type, the name of the variable, and then, if we want to, we can set it equal to a value. For example, here, we have the declaration of a variable. We want to declare an integer, which is a number, called random, and in it we would like to store the value 16. At a later date, when we want to retrieve this value, we can simply call for the value stored in random and get this back. Again, if you've programmed before, this isn't a revolutionary concept. But one thing you might have noticed is that we do need to declare the data type of a variable, and this is not something that we need to do in other languages. Well, this is because C is a powerful language, and you might have heard this said before, but what does it actually mean? In this example, we have the string subscribe to AstroCode, and below it, I have put the binary representation of this text. Computers only understand ones and zeros, and so anytime we want to store some different information, we need to come up with a scheme to be able to store that information. In this case, we use a mapping called ASCII, which maps certain ones and zero combinations to other letters. In this case, every bit, 8 bits, which is a byte, as you can see, broken up here by the spaces, represents a different letter, and you can see this mapping. However, if we just look at 1 byte of information, this could represent all manner of different info. For example, in base 2, this binary number represents the number 115. However, in the ASCII spec, this number refers to the letter S, and in some other schema, it might refer to something else. And the computer doesn't really care or know about the difference between any of these, because it can only understand and store binary numbers. This is why, in a C program, we need to dictate the data type to the program. It means that when it looks up that information, it knows how to interpret that binary code, and can read it as, in this example, an integer. So why don't we have to do this in things like Python, MATLAB, and JavaScript? Well, that's because these are high-level interpreted languages, and the process they use for storing variables is a bit more complicated. In those languages, when we request the value of a variable, it first has to look up what data type was stored in the variable, and then perform any necessary conversions to a different type of information before it reads that value from memory and can understand what those ones and zeros mean. In C, because we've explicitly defined what type of information is stored in our variable, all we have to do is read it from memory. And this is a lot faster. And one of the many reasons why C is so quick. Of course, this is a bit simpler than what is actually going on, but I just wanted to give you a bit of an intuitive idea as to why it's important for us to tell the computer of our data types. If we don't, it has to spend a lot of time and valuable processor resources on determining what kind of information might be stored in those ones and zeros. Whereas if we just tell them, then it cuts a lot of the time out. Now, this was very abstract, so we're going to jump over to our editor now and actually see what variable declarations look like in practice. Okay, so this is the boilerplate code we sort of had last time. I've stripped a little bit out of it, but this is more or less what we were left off with in the last example when we were coding. So we have our main function, which is what runs when we first compile our program. This is what the computer looks for, so we need to have it. And what we're going to do now is play around with some variable declarations. So let's say we want to store a number or some information in the form of a number. We're going to come inside of our main function here. Notice that when I say inside, I mean between the opening and closing brackets, which define this function body. And inside, we're going to make some sort of declaration. So let's say we want to store a number. We can create an integer variable. Now, an integer is any whole number. So 1, 2, 3, 4, 107, or negative numbers as well. -1, -2, -3. It simply cannot have a decimal. So to declare an integer variable, we need to use the int type definition, and then we need to give it a name. So let's call it our number. After this point, we can set it equal to some value. Let's say 10. Perfect. So now we can read this as create an integer, called our number, and set it equal to 10. Now, why is this useful? Well, it's important because it means that if we want to retrieve that information later, we can easily. The standard.io header file that we looked at a little bit in the last episode includes a function we can use called printf, which we also saw, which simply prints some information to the screen. If we provide it with a string, say my number and colon and %d, then after it we can simply put and our number here. Okay, so what is this doing? Well, printf normally just prints whatever we put inside the quotes here. However, if we give it a percentage symbol and some certain character definitions, it can actually print out the values stored in variables. Now, %d actually corresponds to printing out a decimal number. And to be honest, %i is probably what you should use for an integer. But because numbers are sort of flexible, we can just use %d and it will still print our integer just fine. So saving this and then compiling it using gcc main.c and then tac-o and then what we want to output it as, which we're going to just put main.exe. And then running this file, you can see that my number 10 gets printed to the console. That's because in this instance, our variable is referencing another variable. Here, let's create another integer called our other number, for example, if I can type that is. Here, it is now possible to set our other number equal to our number multiplied by 3. So here we've got a variable that references another variable. So how does this work? Well, we declare a new integer variable called our other number, and then we set it equal to this expression. When the compiler reads this, it will look up the value stored in this variable and multiply it with 3. If we then print out our other number down here and save, and then make sure once you've saved your file to actually recompile it again. It's a common mistake to forget to recompile it, and then you'll be confused as to why nothing's changed. So recompiling and running our code using main again, we see that in fact my number is 30. So you can see it's working. Now, why is this useful? Well, it means we can implement a simple tool. Let's look at a tool that converts from Fahrenheit to Celsius. Okay, to start, let's delete our current information and let's insert a new variable called integer. And actually here, we're going to do something different. Because we want to create a program that can convert from Fahrenheit to Celsius, we know that temperature can be a decimal number. It can be 23.4 degrees, for example. So it's more appropriate for us to use a decimal. The main decimal type in the C programming language is called a double. It's called this for some arcane reasons about how precise it is. So don't worry about that too much. Just remember that a decimal is called a double. Let's create a variable called Fahrenheit. I'm not certain I spelled that correctly. And let's just say it's 40 degrees Fahrenheit, 40.3 degrees Fahrenheit, in fact. Okay, so what's going on here? Let's create a decimal number called Fahrenheit and set it equal to 40.3. Now what we need to do is create another double, and this will be for our converted temperature. So we created a variable which is a decimal type called Celsius, and what we're going to do is set it equal to the conversion of this number. If you Google Fahrenheit to Celsius, you can see that there's a pretty simple equation to convert from Fahrenheit to Celsius. In fact, it's 32 degrees Fahrenheit minus 30, well, okay, it's only 32 in this example because that's the default. But basically, it's our Fahrenheit temperature minus 32 multiplied by 5/9, and that gives you the Celsius. So we can implement that in our code directly. So we're going to get our Fahrenheit variable, we're going to subtract 32 from it, and then we're going to multiply by 5 divided by 9. As you can see, this is exactly what Google had told us, and we can actually just pretty much implement mathematical equations directly without any trouble. And let's just quickly check, yes, the spelling is indeed correct. So now when we run our code and compile it, it's going to perform this calculation by looking up what the Fahrenheit temperature is and then store it in Celsius. So let's compile it and run it and see what happens. Compiling and now running it, nothing happened. Now, why is that? Well, it actually did work, but we haven't actually put anything to output information into the screen. So let's bring back our print function. So printf, which stands for print formatted, and then we're going to put Celsius and this, and then remember to put out a decimal or formatted integer, we need to use %d. Then after our string, we can put a comma and then the name of the variable that we want to replace this with. It's a little clunky, but that's how it's done, so you'll just have to deal with it. And don't forget our closing semicolon. Saving, compiling, and running again, if I can find the correct keyboard combination, you'll see that it has indeed performed a conversion. But you might notice something a little bit weird. This number looks way too big. So what's happened? This strange output is actually because our format specifier is wrong for a double. You see, it's kind of confusing, but %d refers to integers. So what's actually happening here is that when we try and print this information, the computer is looking up the value stored in this Celsius variable, but it's forcing it to try and read it as an integer. Remember when we said the computer doesn't really know or care what is represented in binary? It'll just read it and try and convert it to whatever we tell it anyway? Well, that's exactly what's happening here. It's reading this value in binary and just assuming that because we said it was going to be an integer, that it will be. And it doesn't really care about the fact that we've defined it here. C is extremely specific. We must be consistent with our data types. So the correct way of making it print a decimal is actually to use F. I know that's really confusing, but you can actually look up a standard list of C format identifiers. In fact, if you search C format string, you'll probably find a lot of useful resources which describe different format specifiers. Just searching that in Google and pressing on the first link shows a list of all the different types we can use to print different information. And see here, %f is used for printing the decimal floating point values, which is what we've got here. So saving our code, coming back down, compiling it again, and now running it with main, you'll see that the correct temperature actually prints out to the screen. Now to test this, let's try the temperature 0 degrees, because 0 degrees Fahrenheit and Celsius should be the same. In the Fahrenheit and Celsius scale, there is one single crossover point where both of them are exactly the same. So testing -40 in our code, as in -40 degrees Fahrenheit, if we save this and compile it, and then we run it, we should see that -40 degrees Fahrenheit is -40 degrees Celsius. And indeed, we do. So that's just a simple implementation of a program that declares some variables and uses them at a later time. In the next episode, we're going to stop doing so much theory and we're going to focus on just implementing some more stuff programmatically. Thanks for watching.